Welcome. We got a new project for you today. The circuit layout, the actual construction on our breadboard will be very similar to what we've done in the past. We're actually going to introduce a new function today. Up to this point we've learned pin mode, we've learned delay, and we've learned digital write. And the new one we're going to learn today is analog write. So we're going to be focusing on some new code and not so much on some new circuits, although we'll be making some and you'll get more practice, and hopefully by the end of this lesson you'll have breadboards down really well. Alright, let me switch views. There we go. So the parts we need, we're going to need 4 LEDs. I've chosen to use the same color. I'd recommend that as well. We're going to be turning these LEDs on. Previously, our only choice was to have them off or on, 0 volts or 5 volts. We did that with the the digital write. And you may be wondering, well, can't we select values in between? And that's what we're going to show you today. Yes, we can select values in between on and off. And we're going to do that with the new function, which is analogWrite. So to be able to see this, it'll be useful to have LEDs that are all the same color, because we're looking for changes in brightness. Because before it was just on or off, and now we want to try to detect different brightness levels for our LEDs. And then we're going to need the classic 330 ohm resistors, and I've got 4 of those here. Once again, if you're searching through your materials to find these, grab your multimeter, set it on ohms. A little quick review here. Grab your resistor, pinch it, wait for a moment, got a little glare there, about 325, 329, so that looks great. So grab 4 of those. Make sure they're the exact same. If you do grab 4 and they happen to be 220 each, that's fine. If they happen to be 1,000 each, that's fine, but it's really important that all of them are the same size, or I will not be able to show you this dimness or brightness change if the resistors vary, because we can actually change the brightness of our LEDs by switching and having different size of resistors, and that's not what we're trying to accomplish today. We want to keep the circuit for each one of these the same, but we're just going to change the code to make them a different brightness. So let's go ahead and do our construction on our circuit board. So here's my board, and if you recall, the long leg of my diode needs to go to the positive side of my circuit, and I'm going to, let's just straddle the middle part here, and I'll put all of the long-legged sides of my LED pointing towards this red rail, which we, in electronics, we've assigned that color to be positive. So my long leg will be heading towards the positive side. It's not in this rail, but just to remind me that this side is positive. I'm going to use that as a little help. So I'm going to grab the next one. I got the long leg over here. It needs to be pointing towards the positive side. Doesn't really matter where I put it in. It's just going to have one wire on the other side and one on the other. And let's continue this down for that one and that one. And this one I did so fast I'm going to recheck it. So I got the long side. Alright, so for all these LEDs, the long side needs to point to the positive, or head to positive, and I'm going to use that as my positive reference. Then we've got to add our resistors so we don't damage our LEDs, and we're going to make sure these are in the same row and head them off. I'm probably doing a little bit of a different circuit layout than we've done in the past, and that's a good thing. You can see different ways we can wire things up here. Now I'm heading over to this rail. All of these LEDs are going to end up going to ground, so I'm going to make this entire rail next to the blue line. We're going to send that whole thing, send one wire from here all the way into the Arduino into ground. So I can take all of these and send them into this rail. I can save myself some wires, and that'll be nice. So it doesn't matter where along here I put it in. Just got to make sure these two are both in the same row. And off we go. That one there. And one more at the bottom. I'm going to grab a black wire. We often use black to indicate a ground wire. So it doesn't matter where I put it anywhere along that row, because all these resistors are in that same rail. So I'm going to send that right now on the Arduino. We're interested in the digital side still, even though the function we're using is analog. You might think we need to use the analog pins. We're still going to be using the digital pins. So there's a ground way up here. I'm going to swap this and move it to this end so I can have it reach to the ground just like that. Alright, so all these circuits are going to end up going through here and into the ground pin. Okay, now we've got the other wires. I'm just going to choose some different colors. Blue for that one. Just got to make sure in the same row as my LED. Each one of these needs a different wire, because we're going to send each one of these to a different pin on our Arduino, because we're going to code it so that each one does something different. We're going to change the brightness of each one of these separately using analogWrite. So I'm going to reach these back over. Now here's a really important point I need to make sure we talk about just for a moment. See if I can get something to point with. This pencil over here. Now the printout on the different boards might, depending on who makes them, it might be slightly different. But on this one, which most of you have, right here it says digital pulse width. Excuse me, it says PWM. It doesn't say pulse width modulation. That's what PWM stands for. And a little squiggly line, which you can barely see. Right there. I'll draw it a little big on this paper. It looks like that. Little squiggly line. And next to some of these pins, each of these pins right over here are numbered, starting with 0 all the way up to 13. Next to some of them, you see that little squiggly line. There's one there for 3, 5, 6, 7, 8 are skipped, and 9, 10, 11 have those little lines. Okay? These pins, the ones with the squiggly lines next to them, are pulse width modulation pins. They're special pins that we can use to trick a digital pin and making it look like an analog pin. There's a little trick we can use to make it appear as if it's analog. So digitally, normally it's off or on. With these pins, we can make it seem like it's some value in between. So if on is 5 volts, and we would like to have, say, 3 volts or 2 volts or whatever, then we need to use these pins to make it think it's not on or off. Now we'll get the code going and I'll explain a little more about that. So we got to select those. I'm going to just start from the top. My red wire, I'm going to do 11, and the next one 10, 9, and I'll skip and go to 6. So let's go ahead and do that. First one, 11. It's also helpful, I don't know if you noticed, but along here we got the numbers repeated. Help me make sure I get them in the right spot. One there, and one way over to 6. Just like that. Alright, so our circuit is complete, other than attaching this to the computer to download it. I'm going to come back to that in just a second. Let's go over here and write our program. We're going to use, we got to tell our Arduino which pins we're using and whether they're going to be outputs or input pins. Are we sending information out of the wire, or are we taking information and putting it into our Arduino? and this time we're taking things out of the Arduino and sending it to the LEDs. So we got to tell each pin that that's what's going to happen. So we need pin mode. It didn't change colors. We've seen this function before. And we'll start with pin 11, output, like that. We end our function with the semicolon. This function right here requires 2 parameters. A little recap, doesn't hurt to have me repeat things. This is the pin we're using, this is what we want the pin to be, and you think of that as our end of our sentence. Pin mode, and we're dropping to 10. Output, next line, pin mode 9. The last one, we're dropping down to 6, and that's an output. Okay, now of course we could have copied and pasted maybe or whatever and printed to save ourselves some time instead of writing each one of those, typing each one of those out. But this works. Alright, so now we're going to use a new function, which is analogWrite. I can type here. Nope, I still can't type right. A-N-A-L-O-G, analogWrite. Alright, change colors. This function also has 2 parameters, 2 inputs it needs. It needs to know what pin you're talking about, so we'll have to say pin 11, and what we want pin 11 to do. Here's the trick that's going to occur. Normally, let me do a comparison here. Don't type this in, but before, man, I'm typing too fast. This is the one we used before, and we would have said pin 11, alright, be high or be low, and we can make it light up or go low and have it have no current coming out of our Arduino. This time around, we're going to put a number in here between 0 and 255, and 0 will be as if would be like a low, would be exact same as a low, digital write low, and 255 would be the same as a digital write high. And we also have options in between now. We can do 1, 7, 12, 47, and so on. And selecting these other numbers is what's going to give us the allow us to control how bright the LED is. Now for my advanced students, basically what we're doing is with the analogWrite, because it's not technically, we're not actually sending an analog information. It's still digital, but we're turning the digital signal on and off rapidly. So for example, if it's always on, then of course it's just high, right? If it's always off, it's just low. But if I turn it on and off, so it's halfway on half the time and off half the time, then it'll appear from our perspective that the LED is getting half as much voltage, like 2.5 volts instead of 5. So we're this little trick we're doing by flicking it on and off. So let's make this first one as bright as we can, and we'll make that 255, and you might be asking, why 255? Why is this number not 47 or 12,000, whatever? Why 255? Because that is 8 bits. I'm not going to go over bits right now, but you can look that up. Technically, it's 256 for 8 bits if we're counting in zeros and ones, but we include the 0, so we are at 255. If you want to pause and look up 8 bits. Okay, so let's get rid of this one. So this function accepts an 8-bit parameter. So this is high for the first one. Let's make the next one number 10, pin 10. Let's make it a bit less. Let's drop down to say 125. analogWrite 9. Drop down to say 50, and one more for the last pin. Let's turn this one, well, that was a 6, let's turn this one completely off, make that 0. Okay, let's go ahead and upload that. So I'll grab my USB. I'm using the USB, I think this is a type, the full name is USB type, I'll probably get this wrong. I think it's type B Mel. You might have a mini for yours, but I think almost everybody has one of these. Should be in your kit. I'm going to plug this end in to my computer. Oop. Come on, Mr. Brower, you can do it. There we go, 2 hands. And we'll plug this one in here. Now I've got to make sure I've got the right board, so go to Tools. I've got the right board. It's an Arduino Uno. I mentioned already that there are lots of boards, lots of different boards. In our class we have the Uno, we have the Nano, and we have an MKR, and that's about it. And then it's already selected a port, so I'm going to leave it. So technically I didn't have to change anything. You might have to change something. Your port might be empty or nothing there, and you have to select something. Okay, so let's hit this one, upload. It's going to upload and compile. It's going to translate all this. It's going to look it over first and see if there's any errors. And it'll give me a little readout at the bottom here, trying to help me decipher what the error is. And I don't have any. And then it'll take this and translate it into zeros and ones, and then it sends that off to the Arduino. So everything looks good. All right. And let's take a look. This is going to be a little interesting because from the camera perspective, it looks like all 3 of these are still the same brightness and that one's off. However, maybe if I turn it sideways, from my perspective, from using my eyeball, it is pretty clear that this is the brightest one. That one's a bit dimmer and that one's even more dimmer. But let's see if we can exaggerate this a little more so I can show you. Yes, it is actually getting more dim. Now when you do this, you'll see it with your eye, not the camera. But just for a minute here, let's make this more extreme. And you're welcome to toy around with the program as well, however you'd like. Let's drop down to, let's do 75 for that one. Drop way down. And maybe 15. Make it even more extreme. Let's go ahead and upload that and get a more distinct brightness level here. Waiting for it to compile. Give the cat a little squeeze here while we wait. Alright, it's done. Alright, so I try to make it more extreme, and still from the camera view, it looks like that these 3 are the same brightness. If I go sideways, it's actually in the base. Actually, you can get some detection that is definitely brighter and less and less. But for my eyeball, it's completely obvious that that one is much dimmer than this one. Okay, so there we go. We can use analogWrite, and we'll use, it's a little tricky here because we're using digital pins and a function that says analogWrite. So you can get confused and think analogWrite, I need to use analog pins, but we're basically tricking these pins by flickering them on and off so that we can get different values coming out and achieve this different brightness level. Okay, I think that is good for this lesson. So we'll give the cat one more squeeze here and we'll call it a day. Thanks for watching. We'll see you in the next lesson.